Hello, I'm Jarsodullah Chidida. This is to present multimedia data processing assignment one. As given task is image processing, I have done image classification using convolutional neural network. On the data sets, Fashion-MNIST. So the task is Fashion-MNIST image classification using convolutional neural network. Within my task, prepared this PPT. And also there is a implementation, which is a program from Google Colab, like this one. This is the program. So I will try to present both of them parallelly within the time I have. First, I started by stating the problem that will be fixed by these tasks. Automating fashion items or image classification is very important. Automating fashion item classification is very important in many ways, like in e-commerce platforms, in inventory management, and in AI-powered recommendation systems. It's very important. Why it is important is that manually classifying images or manually classifying fashion items is inefficient, prone to error, and time-consuming. That's why automating this classification is very important. And as I have said, I have used convolutional neural network, which provides an efficient and a scalable solution to classify different clothing types from the image. And when I proceed with saying something about the dataset, as I have said, I have used Fashion-MNIST dataset, which is built-in dataset. Here, for purpose of this task, I can access dataset in many ways. I can download it in the save it into my local storage or local storage of my computer, and also I can save the dataset to my drives, and I can access from the drive, and also I can access directly by importing required libraries. So now, from those options, I have used built-in dataset, which without storing them in local storage, without storing them in the drive, directly by libraries, by downloading, by importing required libraries, I access them. So it is built-in dataset, which contains 70,000 grayscale image, 28 by 28 pixels across 10 fashion categories, across 10 fashion classes. These categories are like t-shirt or top class, trousers categories, or trousers class, pullover class, dress. The images are each of the image. These 70 images are under those categories, under those classes. So now our model should tell us the correct categories of that, from which category the input image is taken. Then there is implementation steps. Within implementations, I started by importing required library, then loading in the pre-processing data, then building CNN or building convolutional neural network model, then training the model, evaluating the model, plotting accuracy or loss curve, and then at the end I make a prediction like to now the ground truth and the prediction by my model. So when let me say something about each of them. This is the required libraries which I have imported, as you can see here in the program. So you can see here, I have put them separately. Look, this is the library which I have imported. They are here also, but I separated them for to be good for clarity for presentation. I put them separately. Those are the required libraries. Import TensorFlow as if this TensorFlow is just a framework for building, training, and evaluating CNN, this model. TensorFlow import Keras, this is for accessing the dataset. Import num.py as NP. This is for efficient access of numerical operation. And at the end, matplotlib.py plot as PLT. This is for visualizing taken image from the dataset and also for visualizing this curve. And then the next one is loading and the pre-processing the data. As you can see, Fashion-MNIST dataset is loaded directly from TensorFlow Scala API, consisting of grayscale images of fashion items along with their levels. There is training and the testing dataset and inspected for shape consistency. And then also in loading stage, not only loading, but also I visualize sample images. I visualize sample images. Look, as you can see here, this is after libraries are imported, then this is the same. This is the same with this one. It is just the library. I separated them in above for clarity. Here, load dataset, print dataset shape, class labels, and show sample images. Look, showing the sample image. Those are the sample images with corresponding categories or with their corresponding class. And then after that, pre-processing. Look, before coming to pre-processing, look, to visualize the data, set of sample image from training set is displayed. What I have said. Why it is displayed is that this step helps to confirm that the data is correctly loaded and provides an initial understanding. Initial understanding is of image content and the level distribution, which is essential before proceeding to model training. Then after loading and showing the sample images, I proceed with pre-processing, normalizing the image and the reshaping to produce this result and building the models. This is the program for building the models and even compiling the model. It includes many things as you can see here, because I don't have more time to present all of them. This is the results of building the model and the training is there. Training after building, there is training. Training, this is the program for training. My model trained for 10 epochs. By this 10 epoch, it gives good accuracy, which is above 91%. Look, those are the, while it is training, look, accuracies like about 91 point something percent, as you can see here. Look, I have tested even, test. And this is accuracy, test accuracy. And then plotting accuracy or loss curve. Accuracy or loss curve. This is program for doing that. As you can see here, this is accuracy or loss curve. Train accuracy, validation accuracy. Look, train accuracy is increasing, but train losses coming to zero. This is that one. So like this training accuracy in the loss curve. Yeah, this one. And then at the end, I compare what ground truth or the actual image and what my model predicts. I check that. This is the program to do that. Then by taking the image, look, the predicted one is trousers. So you can see here, the predicted one is trousers and the actual is also trousers. Predicted ankle boat, actual ankle boat. Predicted coat, actual coat. Predicted bag, actual bag. Predicted dress, actual dress. And also this is that the same way in the text format without image. Actual ankle boat, predicted ankle boat. Actual pullover, predicted pullover. Actual trouser, yeah. So what my model predicting is the same with actual images. And this is the architectures as I have tried to present in this building CNN model. It has many layers. The layers are like there is input layer to take input from the dataset, then convolutional layer 1 to extract lower level features, then maximum pooling layer 1. This maximum pooling layer 1 is for down sampling, for compressing, I can say. Then again, convolutional layer 2 to detect complex features, and then again, maximum pooling 2 to compress again or to down sample, then fully connected layer for converting extracted feature into final classification, then the output. This is the features of how this convolutional neural network goes. This is all. This is what I presented in the programs. This is all. I touch it. I presented all important points. I said all important points. This is all. Thank you so much. Thank you. Bye.